Hello everyone! In this video we will work out an exercise together about the burning candle. This exercise aims to test your knowledge of phase transitions and enthalpy and your ability to apply these concepts to real-life situations. Let's look at the exercise. We have a candle that consists of two parts. We have a top part that is completely made out of wax and the bottom part which is a tall holder for the candle. The candle is inserted in this holder, which has a 2.5 mm thick wall made of iron. The combustion reaction equation of burning the wax is given, and some properties are given which are useful for the next questions. Let's start with the first question. If 1 gram of paraffin is completely combusted, how many liters would the volume of gas increase? We have to find the volume change, which can be determined by subtracting the volume at the start from the volume at the end. The volume at the start can be calculated by multiplying the number of moles by the molar volume. The molar volume is 24.5 liters, and the amount of moles you can find from the reaction equation is 61. Note that the moles of wax do not count because they are a solid phase and not a gas. In the same way, we can calculate the volume at the end. The change in volume can be calculated and gives an increase of 514.5 liters. The next question is the reaction endothermic or exothermic? Do you remember that when the heat of the reaction is bigger than zero, energy is needed for the reaction to occur, and this means that it is an endothermic reaction. When the heat of the reaction is smaller than zero, energy is released, making the reaction exothermic. In this case, the heat of the reaction is minus 40,000, well below zero. The reaction will release heat and is exothermic. Let's move on to the next question. How much heat is not absorbed by the candle per hour if we assume that 1 gram of paraffin combusts per hour and that the starting temperature of the paraffin is 20 degrees Celsius? Two assumptions are given in this question. First, none of the molten candle is lost. And second, besides the 1 gram of combusted candle wax, no other wax is heated during this hour. We should ask ourselves where heat is produced and where it goes away. Heat is released through the reaction, and it is used to change the temperature and melt the wax. This gives the following equation. Now, let's calculate each of the terms. The heat released in 1 hour can be calculated by multiplying the mass with the heat of the reaction. This will be minus 40,000 joules per hour. The heat consumption for the candle can be calculated by the well-known equation. Q is m times specific heat times delta T, which gives 75 joules. Last, we will calculate the heat of melting, which is the mass times the heat of fusion, giving 200 joules. Filling all these numbers into the equation gives a total of 39,725 joules per hour. That is not absurd. This energy is enough to heat up 1 kilogram of water by 10 degrees. This is not the real situation though. In reality, a lot of energy is also lost in the form of light, and not every gram of the paraffin will combust completely.